In Chapter 5, we're going to deal with inductive and deductive reasoning. Now, broadly speaking, there are two general categories of logical reasoning. There are arguments that are designed to prove the conclusion with absolute certainty, and these are called deductive arguments, and we've already explored some of those. In a properly constructed deductive argument, if the premises are true, then the conclusion will be absolutely true. So, an example that we used previously, all mammals have kidneys, all dogs are mammals, therefore all dogs have kidneys. Now, if the premises are true, and they are, it is true that all mammals have kidneys, it is true that all dogs are mammals, then the conclusion definitely is true. All dogs have kidneys, and it is. But not everything in life can be known with absolute certainty. We often make arguments about what is probably true, what is likely to be the case. And this is called an inductive argument. In a properly constructed inductive argument, if the premises are true, then the conclusion is very likely to be true, but not absolutely certain. So it's probably true, but there's a chance that it isn't, even if the premises are true. So here's an example of an inductive argument. Golden retrievers are usually very sweet-tempered dogs. That's the first premise. I just adopted a golden retriever. That's the second premise. Therefore, it will probably be a very sweet-tempered dog. That's the conclusion. Now, that's a very reasonable argument, isn't it? But it's not absolutely certain. The premises are true. It is usually the case that golden retrievers are very sweet animals. But I might have adopted an exception. I might have adopted one that has some kind of behavioral problem. So the conclusion is not absolutely guaranteed, even though the premises are true. That's inductive reasoning. Now, we use inductive reasoning every day. When we look at the weather forecast and it shows a 90% chance of rain, we bring an umbrella or wear a rain jacket when we're going outside because we figure it will likely rain. Of course, it may not. A 90% chance of rain means that in the past, when the atmospheric conditions have been comparable to what they are today, on 90% of those days, it rained. So if you think it will rain today, 90% of the time, you will be right. And that's the point of inductive reasoning. It's not to be right all the time. We can't do that. We don't have that capacity. But often we have enough information we can form a reasonable guess in which we will be right more often than we will be wrong. That's the point of inductive reasoning. It's very often the case that deductive arguments, those that establish the conclusion with certainty, often move from a more general premise to a more specific or more constrained conclusion. And so, for example, when we talk about all mammals have kidneys, that's pretty expansive because I'm dealing with all mammals. And then I conclude all dogs are mammals, and then I conclude all dogs have kidneys. That's a smaller claim, isn't it? Because I started with the claim all mammals have kidneys, and then I've ended up with the conclusion that all dogs have kidneys, where dogs is a much smaller sample than all the mammals in the world. It doesn't have to be that way, but it's very often that way with the deductive argument. Now, inductive arguments can go either way. They can draw a more specific conclusion from a general premise, or they can go backwards. They can start with very specific instances and draw a more general conclusion. So an example of this would be if you take a pencil and you let it go and it falls to the ground. Okay, try it again. Pencil, you let it go, it falls to the ground. Try it again, falls to the ground, and so on. Suppose you do this 57 times. Every time it falls to the ground, and you say, you know what, I think pencils always fall to the ground when you let go of them. That would be a general conclusion that you're drawing from specific instances. Now, you don't know that it's true, because it could be that on the 151st time you let go, the pencil just hangs there. Now, none of us expect that to happen, but my point is you don't know from experience that that won't happen. All you know is that in your limited experiences, pencils always fall when you drop them, and you conclude that that is always the case at all times. That's a much more expansive conclusion than the particular instances that you've tested. The process of drawing a general principle from many specific instances is called induction. And God has designed our mind to be able to infer a general pattern just from seeing many specific instances. It's a rather amazing gift, actually. Induction is one of the main principles of science. We look at the universe, we look at certain specific instances, and we draw a general conclusion about the way that God upholds his creation. And the only reason science works is because God has placed patterns in nature and has designed our minds to be able to guess the pattern from seeing specific instances. Inductive arguments are not attempting to absolutely prove the conclusion. That's the thing to remember. They're simply trying to establish that the conclusion is likely. It's probable. If an inductive argument is good, if it really does show that the conclusion is likely, then the argument is said to be strong or cogent. So that's what we're aiming for when we make an inductive argument. We want to make a strong argument, a cogent argument, where the conclusion really is likely to be true. If, on the other hand, an inductive argument really doesn't establish that the conclusion is even likely to be true, then the argument is said to be weak. So we want to stay away from weak inductive arguments. Now, for deductive arguments, we're going to use different terms to indicate whether the argument is good or bad and in what way. And those we will cover in Chapter 12.